Grounding a 400 amp service when using two 200 amp panels requires careful attention to detail to ensure safety and compliance with electrical codes. The proper grounding system protects against electrical shock and helps to prevent damage to equipment. Here's how to ground a 400 amp service with two 200 amp panels. Firstly, ground rod connections are essential. Connect a number 6 American wire gauge, or AUG, bare copper ground wire from each panel to a separate 8-foot ground rod. Drive the ground rods at least 2.5 feet into the earth and ensure they are at least 6 feet apart. Use ground rod clamps to securely fasten the ground wires to the rods. It's crucial to use separate ground rods for each panel initially to ensure effective grounding. Now, concerning panel connections, connect a number 6 AWG bare copper ground wire between the grounding terminals of the two panels. This creates a common grounding path between the panels, ensuring that both panels are at the same electrical potential. Thirdly, address the cold water ground connection. Connect a ground wire size according to National Electrical Code Table 250.66 from one panel to the nearest cold water pipe. The size of this ground wire is determined by the size of the service conductors and the distance to the cold water pipe. Also, connect a second ground wire of the same size between the two panels, ensuring that both panels are connected to the cold water ground. After completing the connections, it is vital to perform a verification of the grounding system. You can test the grounding system using a ground fault tester or by measuring the resistance between the grounding conductors and the earth. The resistance should ideally be less than 25 ohms to ensure effective grounding. Here are some additional considerations. It is recommended to use a grounding system consisting of both ground rods and a cold water ground. This provides redundancy in the event of a failure in one of the grounding paths. If the ground rod connections cannot be made within 6 feet of each other, a grounding conductor that is sized appropriately and buried must be used to connect the rods. This buried conductor ensures that the ground rods are effectively connected even when they are further apart. If the cold water pipe is not accessible or suitable for grounding, other options such as a grounding ring or grounding plate may be considered. These alternatives provide an effective grounding path when a cold water pipe is not available. Let's delve deeper into the specifics of each connection to provide a comprehensive understanding of the grounding process. Firstly, the ground rod connections are a critical part of the grounding system. The purpose of the ground rods is to provide a path for fault current to flow to the earth, which helps to protect against electrical shock. The number 6 AWG bare copper wire is commonly used for this purpose due to its conductivity and durability. When driving the ground rods, ensure they are driven deep enough into the earth to make good contact with the soil. The 2.5 feet minimum depth is specified by electrical codes to ensure adequate contact. The 6-foot spacing between the ground rods is also important to minimize the impedance between the rods. Use ground rod clamps that are specifically designed for this purpose to ensure a secure and reliable connection. Secondly, the panel connections are important for creating a common grounding path between the two panels. This ensures that both panels are at the same electrical potential, which helps to prevent voltage differences that can cause electrical shock. The number 6 AWG bare copper wire is also used for this connection to provide a low impedance path for fault current. Make sure to securely connect the ground wire to the grounding terminals of both panels. Thirdly, the cold water ground connection provides an additional grounding path to the earth. The cold water pipe is typically made of copper or steel, which are good conductors of electricity. Connecting the grounding system to the cold water pipe helps to ensure that the grounding system is effective, even if the ground rod connections are compromised. The size of the ground wire for this connection is determined by National Electrical Code Table 250.66, which takes into account the size of the service conductors and the distance to the cold water pipe. This table provides the minimum size of the ground wire required to safely carry fault current. When connecting the ground wire to the cold water pipe, make sure to use a clamp that is specifically designed for this purpose. The clamp should be made of a material that is compatible with the pipe material to prevent corrosion. Also, the clamp should be installed on the street side of the water meter if possible. This helps to ensure that the grounding system is effective even if the water meter is removed. After completing all of the connections, it is important to test the grounding system to ensure that it is working properly. A ground fault tester can be used to simulate a ground fault and verify that the grounding system is capable of safely carrying fault current. Alternatively, a multimeter can be used to measure the resistance between the grounding conductors and the earth. The resistance should be less than 25 ohms, as specified by electrical codes. If the resistance is higher than 25 ohms, it indicates that the grounding system is not effective and needs to be improved. This may involve driving additional ground rods, improving the connections to the ground rods or cold water pipe, or using a different grounding method. In addition to the above considerations, it is also important to ensure that the grounding system is properly maintained. Ground rods and connections can corrode over time, which can reduce their effectiveness. It is recommended to periodically inspect the grounding system and make any necessary repairs. This may involve cleaning the connections, replacing corroded components, or driving new ground rods. It is also important to ensure that the grounding system is not damaged during construction or other activities. Ground rods can be easily damaged if they are struck by heavy equipment. If a ground rod is damaged, it should be replaced immediately. Let's further discuss the importance of redundancy in the grounding system. Redundancy refers to having multiple paths for fault current to flow to the earth. This is important because it provides backup in case one of the grounding paths is compromised. For example, if a ground rod connection corrodes, the fault current can still flow to the earth through the cold water ground connection. The use of both ground rods and a cold water ground provides redundancy in the grounding system. If one of these grounding paths is compromised, the other can still provide protection against electrical shock. In addition to ground rods and cold water grounds, other grounding methods can also be used to provide redundancy. These include grounding rings and grounding plates. A grounding ring is a loop of bare copper wire that is buried around the perimeter of a building. A grounding plate is a large metal plate that is buried in the earth. Both of these methods provide a large surface area for contact with the earth, which helps to reduce the impedance of the grounding system. Let's delve into the specifics of National Electrical Code Table 250.66, which is used to determine the size of the ground wire for the cold water ground connection. This table takes into account the size of the service conductors and the distance to the cold water pipe. The size of the service conductors is determined by the size of the electrical service. The larger the electrical service, the larger the service conductors. The distance to the cold water pipe is the distance from the service entrance to the point where the ground wire connects to the cold water pipe. The longer the distance, the larger the ground wire that is required. National Electrical Code Table 250.66 provides a table of ground wire sizes based on the size of the service conductors and the distance to the cold water pipe. The table specifies the minimum size of the ground wire that is required to safely carry fault current. It is important to use the correct size of ground wire to ensure that the grounding system is effective. Using a ground wire that is too small can result in a higher impedance grounding system, which can increase the risk of electrical shock. It's important to remember that electrical codes and regulations can vary depending on your location. Always consult with a qualified electrician or local building inspector to ensure that your grounding system complies with all applicable codes and regulations. Proper grounding is essential for ensuring the safety of your electrical system and protecting against electrical shock. By following the steps outlined in this explanation and adhering to all applicable codes and regulations, you can create a safe and reliable grounding system for your 400 amp service. Consider the importance of proper documentation of the grounding system. Keep detailed records of all grounding connections, including the size and type of ground wires used, the location of ground rods, and the results of grounding tests. This documentation can be helpful for future maintenance and troubleshooting. Also, remember to label all grounding conductors and connections clearly. This will help to ensure that the grounding system is properly maintained and that any future modifications are made correctly. In conclusion, Grounding a 400 amp service with two 200 amp panels requires careful attention to detail and adherence to electrical codes and regulations. By following the steps outlined, including ground rod connections, panel bonding, cold water grounding, and verification testing, you can create a safe and reliable grounding system. Remember to prioritize safety and consult with a qualified electrician if you have any questions or concerns. Effective grounding is not merely a requirement, but a critical safety measure that protects people and property from the hazards of electrical faults. Ensuring the integrity of the grounding system through regular inspections and maintenance is an investment in safety and peace of mind. Additionally, consider the long-term effects of soil conditions on the grounding system. Soil composition, moisture content, and chemical properties can affect the conductivity of the ground and the corrosion rate of ground rods and connections. Periodically test the soil resistivity and adjust the grounding system as needed to maintain its effectiveness. In areas with highly corrosive soils, consider using corrosion-resistant ground rods and connections to prolong the life of the grounding system. Furthermore, consider the impact of future changes to the electrical system on the grounding system. Any modifications to the electrical service, such as adding new circuits or equipment, may require adjustments to the grounding system to ensure that it remains adequate. Always consult with a qualified electrician before making any changes to the electrical system to ensure that the grounding system is properly maintained. Finally, never underestimate the importance of ongoing education and training in electrical safety. Stay informed about the latest electrical codes and regulations and participate in continuing education courses to enhance your knowledge and skills. By staying up to date on the latest advancements in electrical safety, you can help to prevent electrical accidents and ensure the safety of yourself and others. The grounding system is the unsung hero of the electrical installation, and it functions silently in the background. Its role is to instantly and safely divert dangerous fault currents, thereby preventing electrical shock, fire, and equipment damage. The quality of the grounding system directly correlates to the safety and reliability of the entire electrical system. This is why a thorough understanding of grounding principles, correct installation techniques, and vigilant maintenance procedures are indispensable for anyone working with electrical systems. Remember that electrical work should always be performed by qualified individuals who have received proper training and certification. Attempting electrical work without the necessary knowledge and experience can be extremely dangerous and can result in serious injury or death.